Moving into our next keynote by Dr. Dipesh, Executive Vice President, President and GM IoT Services Group, ARM. A brief introduction before I invite him on stage. Dipesh, as I just mentioned, is the President of IoT Services Group of ARM, and prior to this, he served as the Executive Vice President of Incubation Businesses, responsible for the development of new businesses to create solutions to enable the Internet of Things. Dipesh was previously Executive Vice President of Technical Operations in the charge of ARM's infrastructure used for IP development. Before this, he was General Manager of the Physical Design Group at ARM. Ladies and gentlemen, please extend a warm welcome this afternoon to Dr. Dipesh.
Hi, everyone. Good afternoon. First, it's really good to be here. I'm still waiting for that clicker, but we'll keep going. I run the IoT Services Group, as the introduction just said, and I think you're probably wondering, I work for ARM, what does IoT Services mean? What I'm actually going to talk about is not hardware. I'll reference hardware. I know one of the questions that was asked just now was, are there going to be enough silicon chips to keep all the fabs busy? And I firmly believe there's going to be lots and lots of demand for IoT chips that are going to keep those fabs busy for a very long time. And the reason for that is actually, as you will see later, the possibilities of what IoT gives you is only limited by our imagination, right? And as long as our imagination can run wild, people will find different problems that they can solve with those IoT chipsets, right, and the sensors. Thank you. So what I wanted to do is, when you think about those chipsets and all the sensors, what does that actually mean? What are the challenges that start coming up? So I'm going to talk a lot about the challenges. I'm actually not going to spend too much time on any potential solutions, although I do have a slide to just describe very briefly what we are doing at ARM. But today I really wanted to talk about the challenges that exist to unleash this world of data. Right? I think everybody has heard about how data is the new economy. It's like the new oil. A lot of that data is growing exponentially from multiple reasons, right? One of the reasons is because consumers now have access to internet all the time, so they're consuming more and more content. But actually, as the world gets more and more connected, as you get more and more devices deployed out in the world, it's going to create even more data, so even more exponential growth in data. And if you want to take advantage of that data, you need to be able to get those devices designed, connected, deployed, before you can actually get the data. So what I wanted to spend time today was on the challenges for that. So I think you're all familiar with the waves of computing, but if you're not, I'll just briefly describe them. We are about to enter what we call the fifth wave of computing. That means there are 4 other waves that have been before us. The first wave was mainframes. Mainframes were interesting because it was the first time that businesses started to use computers and found a way to increase their productivity. Then came the personal computer. The personal computer, for me, is my favorite wave because actually it created a foundation. It was the first time that every employee in a business got access to a computer, right? It enabled that to happen. But more than that, it meant all of us, at some point over the next 20 years after that wave, started to have PCs in our home. It actually created a platform so developers could then go off and develop apps. Obviously, in those days, it was all mostly Microsoft Windows-based, but that seeded the foundation for what was to come later. The third wave was the internet wave. Internet wave is, again, very interesting because it created new businesses. It also destroyed a lot of businesses, like older school businesses that were reliant on traditional ways of doing business got destroyed. So the internet wave created another wave of innovation. And then finally, of course, there was the whole last 10 years have been about the smartphone and what the smartphone has enabled. It's actually enabled a new way of living for you, me, a new way of working as well. new businesses have grown up that we could not have imagined. For example, ride sharing and ride hailing. Nobody could have predicted that when the smartphone first came out. And it became possible because of the imagination of certain people and what they realized they could do with a smartphone. And I think the same will happen with the fifth wave. And the fifth wave is I think, what we are going to go through now. I can't tell you whether it's going to last 10 years or 20 years, but it's going to be fueled by a number of different factors. One of those factors is IoT, which to me means there'll be millions and billions of devices sensing, measuring, creating different types of data. So that's the first thing that I think will fuel the fifth wave. The second thing is ubiquitous connectivity. As 5G comes online, we will get access to connectivity at low latency with high bandwidth. That will create more possibilities. And then, of course, you'll get lots more data which will need to be analyzed, and we'll see an explosion, a rise of machine learning algorithms that start making sense of the data that we are generating. So all those three factors together is what will create the fifth wave. So when you then look at IoT, the question is, what are the applications for IoT? And on this slide, it's a very generic slide. I've actually just tried to list some of the applications of IoT in 4 different domains. Each of these domains, connected spaces means smart cities or city environments or building environments. Agriculture, everybody knows about agriculture, but you can think of the possibilities of using smart sensors and control units for better farming, better yield, better water management. In healthcare, there's already trials happening where you can walk into a hospital, you get tagged with a Bluetooth device that can then help you in a number of different ways. The simplest way is to improve the care that you get, right? So from the moment you walk into a hospital to the time you see the first nurse, doctor, to the time you get discharged. That's a very simple use case, but actually there are much more interesting use cases that you can do once you have a patient that you're tagging, and you can help the patient go from point A to point B so that their care can be taken care of. So healthcare is another application area for IoT that I think is going to explode. Similarly, on the bottom right is utilities, which is about 3 different things. It's about generation. So, as we all know, the resources that we have available are limited. So we need to make sure that we can use those resources in an optimum way. So it's about generating electricity or any other type of energy. It's about distributing that energy, making sure that it's available where you need it, and then consumption of the energy. You want to make sure that you understand the consumption cycles. If you understand the consumption cycles, you can then use that information to adjust the amount of energy that you're generating. And maybe you want to use wind farms more than you want to use traditional coal plants. So you can just see from these very simple descriptions what the possibilities are for IoT. Each of those things, of course, needs chips, it needs sensors, and it's going to create a huge demand for all of us in this room. What I wanted to do now is just walk you through a very simple example of how IoT can be used in a retail context. So what I'm showing here is 3 different places. Over on the right is the retail store, so where you and I would go to maybe purchase some goods. Over on the left is the warehouse, the distribution center. And then in the middle is the purchasing department. So the purchasing department is quite hard because they're trying to predict the demand and make sure that the supply is informed so that you get goods at the right point in time and just in time. When you peel the layer back, what you find is that actually the types of devices and the types of sensors that each of the areas have is quite different, right? And so on the left-hand side, you have different types of sensors in the logistics environment or in the warehouse environment. Over on the right, the retail store, you have a point of sale terminal, which is scanning what you're buying. It therefore then goes into the ERP system, adjusts the inventory. That data then goes back into the purchasing department, who collects all the information together and creates some insight. So you can see there's lots of sensors creating lots of data, which is then being combined together. So this is different types of data being combined together. But it's also being combined together with other systems that you have in your company, right? An ERP system, it might be a CRM system if you have a different use case. And then you're creating the insight, something important and interesting that you can do something about. So when you think about how am I going to deploy this solution, right? And you start looking at the what you find is actually there's many different types of devices. So the point of sale terminal that I talked about probably has a screen. It probably has some interactive way in which the cashier is interacting with that device. So that's one type of device. That's what we would call a rich node device. The sensors maybe just monitoring where goods are. Maybe they are just telling you what goods are present. They're probably much simpler devices. If you are transporting fresh goods like food through a cold chain supply, you probably have temperature sensors, humidity sensors, pressure sensors. Those are really simple devices. So that's what you see over on the left-hand side. The point of this slide is that any solution we come up with has to be able to cater for such a wide variety of devices. What you can't do is you can't have bespoke solutions for each and every single thing. You want to try and create a platform. Now, in the world of computers like PCs and mobile phones, we've solved that problem, right? In PCs, we have, I think, 2 operating systems. You know, you have a Windows PC or you might have a Mac OS. In mobile phones, there's iOS, Android, and in India, of course, with feature phones, you have KaiOS. So there's OSs that have emerged that have made it simpler for people who are making devices and developing applications. I think the same needs to happen for IoT when you think about the breadth of devices that exist. So today, that doesn't exist, right? There's many different SDKs that you'd have to buy or get that come with your chipset that you have to use. So if you're writing software for such an application, you have to learn different things. The next thing you find is the device needs to connect to something, right? Most people think it's going to connect into the cloud. The reality, of course, is it actually connects into a hybrid environment. Depending on the segment, for example, if you're in a utility environment, most likely those devices, your smart meters, will connect into a private cloud environment or connect into an on-prem environment. Due to various reasons, regulatory reasons, for example, it may not be possible to use cloud. But in some cases, cloud is also possible. So again, any solution that we come up with has to be able to cater for different targets to solve. Right? I talked about on the device front, when you have devices, you have to be able to cope with the variety of devices that exist. But when you think about, this thing keeps cutting in and out, I apologize. When you think about each of the layers, there are more problems that you have to address as you create the complete solution, right? From a very simple one like managing the device. So if you've designed your device, once it's deployed, you need to onboard it, you need to give it an identity. Shall we change the mic? Sorry. Is this better? Okay, so hopefully this works. I've lost my train of thought now. Okay, so once you connect a device, you have to be able to do a number of different tasks to that. It's called device management. Once you start getting the data from the device, you need to start organizing the data. You know, our previous presenter talked about data organization and ML, big data platforms. Before you can do that, you need to be able to get the data in, you need to be able to organize it, combine it with other things before you can start doing machine learning on it. So you need a data platform that can help you do that. All of this you can do in-house, of course. It's a question of time and money. But there's no value that anybody's adding in this, right? These are mostly common tasks across all the verticals and the use cases that I showed you earlier. So what you really want is a platform. Oh, and before you can get to the platform, you need to worry about security as well, because you want to make sure that nobody can hack into your IoT environment. So security is not only about what you do on the device, but you need to worry about security all the way from the chip to the cloud. So you need some architectural framework within which you can reason about security. So I want to just spend a few minutes about security because I think this is a really important parameter. Today what happens is a lot of these devices that are on the market don't necessarily have all the right ingredients to create a more secure device. So what we've done at ARM is defined a framework. We call it PSA. It stands for Platform Security Architecture. It's a recipe. And the recipe says, if you want to create a secure device, there's a number of things you must do. And that's what we've tried to show you on this slide here. You need to be able to have a unique identity for the device. So on the right-hand side, you can see 4 things. The first one is device identity. If you can't identify your device uniquely, it's not possible to do a number of things that you might want to do with it. Secondly, you need to be able to trust the boot sequence. Right? You want to make sure that when the device boots up, the code on the device is what you expect it to be. And so on. You know, there's a thing about firmware update. You know, a lot of people realize now that the IoT devices that will get deployed will need to be updated. You don't want to send somebody out into the field with a USB stick to update the device. So firmware over-the-air update has to be possible. When you think about that, it creates a number of implications on the device itself. How much memory do you have? Can you download a new image? Can you verify the image? Can you swap it out, etc.? There's a lot of problems and challenges that you have to get through. So what we did was we said, okay, we need to take all of these requirements, put it together into a framework called PSA. And if all the chips can be designed to that framework, then it gives you a common foundation on which you can build a secure IoT network. Just as an example, this is a utility example with a smart meter. So a lot of smart meters today are based on existing silicon. Those silicon may or may not have the ability to do all the things that I described before. With PSA, if you can design it, then not only can you update the device over the air, which creates a level of efficiency that a lot of companies are looking for, but also you're moving away from more traditional security mechanisms for device access. How many people have bought a router and never gone into the admin panel and changed the password? Probably a lot of us, right? I can see at least one hand there. And that's because we are using older ways in which we are securing that device. But modern day internet technology is based on certificates. We think the same will need to be used for IoT. So that's what PSA does. In this example, if you have a smart meter that's designed with that technology, you have a common framework in which you can reason about security, whether it's a smart meter or whether it's a point-of-sale terminal. I talked about data already briefly. I mean, there's a series of steps that you have to go through to process the data before it becomes useful. So what we've done is created a platform that helps you do the ingestion of the data, the organization, and then you can spend most of your time and energy on analyzing the data, because that's where the value is coming from. So these are all the common things that you need to solve before IoT becomes useful. What I want to do next is I want to walk you through an example. So this is a real example. It's actually an aftermarket device. It's a camera that you can put into a car. That camera is connected using a cellular network. So it's basically just capturing images as the driver is driving around. So the car itself is shown on the right-hand side. That car is a device. It needs to be managed along the lines that I described earlier. There's 20,000 cars. They're sending lots of data. So this is data that is streaming live into a data platform. That data platform is also pulling in data from other sources. So you're pulling in weather data, map data, so you can analyze where the car is, what the weather conditions were. As I said earlier, that data is going through a cellular network, so you need to be able to manage the connection itself. Not only manage the device, but you have to manage the connection itself. There's lots of data flowing. There's about 64 gigabytes of data per day that's going up. So any data platform that you have has to be able to scale. Now, you've got all the devices connected. You've managed the network. You're getting lots of data. You're starting to integrate that data with other sources. You can start doing something useful, right? So the first thing you can do is you can track your vehicle, right? You know where your vehicle is. In fleet management, this is actually a very interesting requirement. But because you're combining with weather data and map data, if there's an accident, you can actually send somebody out automatically and make sure that the driver isn't injured, anybody else involved in the accident is okay, and so on. Right? So you can do a lot of this automatically now. But more than that, what you now have is more enriched data. Enriched data now means actually you can do other things. You know, you might actually be able to score the driver, right? That becomes really interesting because as an insurance company, if you know how the driver is behaving, you may be able to adjust the insurance for drivers like me who are very safe and another driver that might not be safe. So this is a very simple example. It's a real example actually of how data from a car was combined with weather data, map data to create new opportunity, right? For you as a company that owns the data, you can now create a new economy based on data. So that's what I think the possibilities are with IoT. And this is an example that we've trialed, as you can see. We can't really, it's with 20,000 vehicles. If you had a bigger fleet, you can do a lot more with it. So this is my only product slide. Just to give you an idea of what we are doing at ARM to help you address the different challenges. So I'll start at the bottom. At the bottom, we are creating an operating system that helps you as a designer to use a standard environment when you're starting to design your IoT software on the device. You don't need to worry about connectivity, security, whether the encryption libraries are correct. We're taking care of all of that for you. Then, as you get into the cloud service layer, again, we're developing a few common layers: the device management layer, the connectivity layer, and the data management layer. So reducing the barrier and the time it takes you from the time you design the device and deploy it to the time you can start using the data that comes from it. And then around it, we are firm believers in ecosystem because we know we can't do all of this by ourselves. Right? That's a very small fragment of what it will take to create a complete solution. So we work very closely with different players across the ecosystem, from silicon players at the bottom, so our semiconductor partners who are building chips, all the way through to app developers on the cloud side. Because once you start getting data, you need to be able to dashboard it, you need to be able to maybe do some analysis, do some machine learning. So there's a whole new ecosystem of players that you have to work with. I think I want to finish with just the final slide is about India. everything I've talked about is very generic right now. We are active in India. The possibilities of IoT in India are huge. Just yesterday we met with a company who is looking at IoT opportunities in home, right? Now, if you have a home, you can think about it, right? You might have a surveillance camera. You might have an AC unit that you want to control. You might have lights. I mean, I'm not a big believer in lights, but you might have a light that you want to control. You might actually have plugs that are smart, so you can turn them off when the washing machine actually finishes and doesn't need to stay in standby. That conserves power. So there's a lot of different opportunities just in the home. Similarly, in agriculture, in utilities, there's a drive by the government to make all the smart meters in India, there's about 300 million meters in India, smart. Right? Smart means that they are connected. You can access the usage at any point in time. And that saves you from sending somebody out to go read the meter. By the time somebody's read the meter, it's out of date, right? Because it's stale information. But if you get live information, you can start doing some real-time analysis and take some real-time action. So I think the possibilities for IoT, not only all over the world, but also in India, are unlimited. And a lot of that can be realized if we have standard environments for some of the common layers. So that's all I wanted to talk about today, but I'm sure all of you have many questions, so I'll open it up for questions.
Dr. Patel, I'm sure in your marketing department list down what are all the opportunities for IoT. It is a big list. But in the field out there, which sector you are seeing are waiting, are ready to absorb IoT solutions, and which sector there is an element of resistance for whatever systemic reasons in adopting IoTs?
So that's a really good question. I think I would say that the way the conversation has changed over the last 3 years. I've been doing IoT in this form for about 3 years. 3 years ago when I started, the conversation was very much about, I don't need an OS and I don't need a device management solution. I'll never update my device. That was the conversation we had. Now the conversation is very different. Across, actually all those examples that I showed you on one of the earlier slides, those are active conversations that we've had. So the conversation is, okay, I think I understand IoT. I think I can see the value, but I need to do a POC. Because they want to see the benefit, right? And so a lot of our conversations actually are across different verticals, different application areas, and it usually involves doing a POC, a trial of some form, so they can get the data, they can start thinking about the value of the data. So we're not seeing much in the way of resistance, other than prove it to me.
One question here. Hi.
Yeah.
One question over here. This side. You all are convinced with the applications of IoT. However.
Oh, sorry. Yeah.
Okay.
Yeah. Now I was looking here and sorry. Yes.
So thing is like from security perspective, what steps are being taken? Let's say from at ARM, at silicon level, if there is anything done. Security.
Yeah, security.
Yes, at silicon level.
I'm not sure I can hear properly, sorry.
Yeah.
At silicon level?
Yes.
Okay, so at silicon level, there's a number of things we're doing. So first is in the CPU, we've got something called Trust Zone. So if you're familiar with the ARM architecture, Trust Zone is now a standard configuration across from our microcontroller range all the way through to the application processors. So at the CPU level, what we're doing is having Trust Zone enabled for the entire range. The second thing we're doing is defining a platform security architecture. That's the PSA work that I talked about. That's actually an SoC level thing. It's not a CPU thing. And that requires working very closely with our semiconductor partners to get them to build their SoCs to be PSA compatible. And then we are also working on the software side, where the OS that we are designing is PSA compliant and can be shown to be certified with the silicon.
There are a lot many efforts already going on software side, but then on silicon side, it's important, I think. That is something not addressed yet. Thank you.
Okay, thanks.
Yeah, Dr. Patel, there have been talks about 50 billion sensors will be connected and it will be ubiquitous connectivity and things like that. 50 billion by 2020. Right now, we are not seeing that number anywhere close to 50 billion or whatever. So that was a hype which everyone lived, and we are living to that hype. The second question is the question of IP4 and IP6, the IP addresses. I am not seeing IP6 being very predominant. Is it because that 50 billion never happened, so this has never happened? What is your thought on that? And why was this hype created
Okay.
in the first place?
Yeah, so I think the 50 billion number for me includes a lot of different assumptions, right? So it's never clear to me whenever I've looked at that 50 billion number, which I think both Cisco and Ericsson has a very similar number as well, have put out. I think it actually includes everything that is connected, right? So that goes from routers to mobile phones to PCs to even sensors. I don't think the 50 billion number is purely based on just sensors. Now, having said that, I agree with you that actually it's a bit of a stretch to see that sort of connected number in the next 2-3 years. But for me, it's really less about the number. I'm actually not too worried about whether it's 50 billion or 20 billion. It's actually forcing us to think differently about the problem. And that's the way I approach it, right? Is to think about the world of IoT where we will have many, many more devices than we have today. Right? Today there are about 2 billion smartphones, I think, sold per year, right? With about 8 or 9 billion phones active at any point in time. With the types of sensors that I can imagine, the numbers are going to be much bigger. And so if the numbers are much bigger, the question really is how do you scale, right? And that's why we think of the number being a big number and figuring out how you can scale the solution. So that's how we approach the problem. I actually don't have any view on IP addresses. I'm not the expert on IP4, IP6, so I don't actually have a view on that. Sorry? Oh, I don't think there's any link.
Good afternoon, Mr. Dipesh. Incidentally, my name is also Dipesh. There's one famous musician who said about Internet of Things that if you think Internet has changed your life, then think again. Internet of Things is going to change all our life again, and in a much faster and a different way. Do you agree with this? And if so, how do you think the world is going to adapt to this Internet of Things?
Okay, that's a very philosophical question. I think the world will change. The world has continuously changed for the last many, many years, right? So I have no doubt that as we get IoT being deployed with much more smarter environment around us, it's going to change the way we work. It's going to change the way we live. I have no doubt about that. Exactly how, I'm not so sure, right? And I think there'll be a generational thing as well. So, for example, my parents struggle to use a mobile phone. They struggle to use an iPad. I mean, they can use it, but as soon as something goes wrong, they're like, I don't know what went wrong, right? So I think that generation will struggle to adapt. And that's where there'll be an opportunity for service providers to come in and actually make their home smart or make their home more intelligent, improve their lifestyle. Right? So there'll be a new industry that will get created for somebody like my parents' generation. For my kids, as my daughter's about 17, by the time IoT becomes deployed and it's everywhere, she'll have grown up with that. So for her, it will be the norm. It'll be a normal environment, right? So she doesn't know any different. For example, when I was growing up, there was the VHS. That doesn't exist anymore. Then the CD came. That doesn't exist anymore. We now stream. My kids have no idea what a CD is, right? Because everything they do is consumed through a streaming device. So I think it will be a generational thing where the younger generation will adapt and will just go with it. Older generation will probably struggle. People like me who are techies will probably be fine. Okay, so I think we're out of time, so thank you, everyone.
I'd like to thank Dr. Dipesh Patel for that keynote presentation. I'd like to request Dr. Satya Gupta, IESA Executive Council and co-founder and CEO of Senso Technologies, to please come up on stage and present a small token of our appreciation to Dr. Dipesh Patel. Thank you once again.